Today we're going to be working on section 6.4, which is solving compound inequalities. That means that we are working with and statements and or statements. We have in English all real numbers less than 10 and greater than -2. All real numbers. That means that we are going to be substituting an x, really any variable will do, in for all real numbers. Means x is going to be less than 10, and, so we're going to put down the word and. We go back up to all real numbers again. X is then greater than a -2. You have two inequalities here connected by the word and. We have to put them together. I find that students do this the easiest if they can put the smallest number on the left and the largest number on the right, and then get their x in between. So smallest number is -2, largest number is 10. Let's get the x in between, and then look at your symbols. You have x is less than 10 here. That means I need a less than symbol over here. They're going in the same direction. Our x is greater than -2, but things are flipped here. So that means we also have to flip our inequality symbol. So we have -2 is less than x is less than 10. And this inequality, which is a compound inequality, is our final answer. We say -2 is less than x is less than 10. It has to be true for both inequalities. X will fall between those two numbers. If we see this as a math problem, we have 2 is less than x plus 5 is less than 9. We need to have as our goal to have x all by itself. So that means that we are going to subtract 5 from all three sections. When we subtract 5 from all three sections, that gives us -3 is less than x is less than 4. Now this compound inequality is our answer, and we're also going to graph this solution. When you are graphing this, we'll only need the two numbers on our number line, -3 and 4, have them in the correct order. We say that x is less than 4. That means I need an open circle on the 4 and an arrow starting to go to the left. And then I have this -3 is less than x, or if I want to read it this direction, that's x is greater than a -3. That is also an open circle and an arrow going to the right. And we connect those to make a box. And anything that is between that -3 and 4 on the number line is a true statement. For example, if I choose the number 0, that falls between -3 and 4. If I substitute 0 in for x, I get 0 plus 5 is 5. 2 is less than 5. 2 is less than 5, and 5 is less than 9. It makes it a true statement for both of them. So I have my compound inequality and I have my graphing. Let's check out -1 is less than x plus 1 is less than or equal to 7. We'll subtract 1 in all three sections. That gives us -2 is less than x is less than or equal to 6. When we graph, that gives us a -2 and our +6. We need a closed circle on the +6, an open circle on the -2. All numbers smaller than 6, but larger than the 2. So that we end up with our compound inequality as our answer and our graphing. This would be worth 3 points on the test. Because we have two answers and you have to keep them together. And then 2 points for the graphing. 1 to have the arrows going in the right direction, and 1 to have the appropriate open and closed circles. So a total of 5 points on your test or quiz for a problem such as that. Let's take a look at this problem where you are adding 3 to each section, such as -2 is less than or equal to -x less than or equal to 5. But our goal, remember, is to have the x all by itself. So we need to make sure and divide by a -1 on each section. And when you divide, that causes your inequality symbols to flip around. And so we actually have +2 greater than or equal to x greater than or equal to -5. This inequality is correct as it is. If you want to flip the inequality around and have the negative on the left and the positive on the right, then you have to flip the inequality symbols around as well. Both of those inequalities are correct, and as long as it's graphed correctly and written correctly with the inequality symbols, I don't care which way it's written. Let's go on to all real numbers greater than 4. Again, all real numbers is going to be our x. Greater than 4 or less than a -3. So we're going to have x is greater than 4. Then we're going to write the word or. And we go back to the beginning of the statement. We say x is less than a -3. This is an or statement, and an or statement does not get put together. We leave it as two separate inequalities with the word or in between. Let's talk about graphing on this. We have -3, we have our +4, x is greater than 4, going to the right, open circle. X is less than -3, open circle to the left. Notice how the two arrows are going in opposite directions. That happens with an or statement. And statement, they go towards each other to make a box. Or statement, they go away from each other so that they are going in opposite directions. And the number is only going to be true for one of the two statements, not for both of them. If we are given some algebra to do as 2x plus 3 is less than 9 or 3x minus 6 is greater than 12, solve these two inequalities independently. So we're going to subtract 3 on both so that we get 2x is less than 6, therefore x is less than 3. And over on this one we'll have our 3x is greater than 18 and x is greater than 6. Bring down that word or in between, and x less than 3 or x greater than 6 is the final answer for your compound statement. We have the 3, we have the 6 on the number line. We need all numbers less than 3. We need all numbers greater than 6. If we choose a number that is less than 3, for example, maybe we choose, hey, x equals 0. If I substitute 0 in for x, I got 2 times 0 is 0. That means I have 3 less than 9, true statement. Up here, if I make this 3 times 0, that gives me -6 is greater than 12. It doesn't make the second statement true, but it does make the first statement true, and therefore it's a good answer. Perhaps I will choose something like x equal to 7. So if I substitute a 7 in for my x, 2 times 7 is 14, 14 plus 3 is 17, 17 less than 9, false statement. But if we do 3 times 7, which is 21, minus 6, that gives me 15, and 15 is greater than 12, true statement. So it made the other one true. It only makes one of the two statements true. We can do one more of these where we add 2 to both sides. 3x is less than or equal to a -9. Therefore, x is less than or equal to a -3. Or subtract 8 on both sides. We get 2x is greater than 8. And when we divide by 2 on both sides, we have x is greater than 4. We have our compound statement, and then you can graph that as well, and the arrows should be going in opposite directions. The last thing that we have is a story problem. The Mars exploration rovers Opportunity and Spirit are robots, yes, I have a typo, robots, that were sent to Mars in 2003 in order to gather geological data about the planet. The temperature at the landing site of the robots can range anywhere from a negative 100 degrees Celsius to 0 degrees Celsius. When we write that, that's a negative 100 degrees Celsius, less than or equal to the temperature in Celsius, less than or equal to 0 degrees Celsius. Now they want us to have a compound inequality that describes the possible temperatures in Fahrenheit at the landing site. Well, you should know that Celsius is equal to 5/9 times Fahrenheit minus 32. So I'm going to substitute what Celsius is equal to, 5/9 times Fahrenheit minus 32, into our compound inequality. And the first thing that we have to do is get rid of that 5/9, which means let's multiply by 9/5 on all three sections. And when we do that, 5 divides into 120 times 9 gives us a negative 180, less than or equal to F minus 32, because the 5/9 and the 9/5 cancel, less than or equal to 0. The last thing that we need to do is get rid of the 32, so we're going to add 32 to each section. That gives us 32 on the right, F in the middle, and a positive 32 added on to that negative 180 gives us a negative 148. So we have negative 148 degrees Fahrenheit, less than or equal to F, less than or equal to 0 degrees Fahrenheit. The last thing that it asks us to do is to identify 3 possible temperatures in degrees Fahrenheit at the landing site. Any number that is between negative 148 degrees Fahrenheit and 32 degrees Fahrenheit would be an awesome answer. You could have negative 130 degrees Fahrenheit. You could have negative 2 degrees Fahrenheit. We could have 6 degrees Fahrenheit, plus many, many other choices. Okay, your homework for tonight is 6.4C or 6.4 workbook. So please come in and ask questions if you need to. Thank you.